Hello students, welcome to this lecture. Today we will discuss on the applications of system of linear equations. What we will do is basically we'll go through the business and economic problems and we'll use that to solve using the system of linear equations. Basically, in this under this topic, we'll go through how to solve the system of linear equations under the application using the matrix algebra and determinant method. So the objective of today's lecture is to solve business and economic problems using system of linear equations. So whenever you are trying to solve the business or economic problems using system of linear equation, you should follow these three steps. First thing is that once you go through the information or data given in the question, first you should transform that information in the form of system of linear equations. First step is to get the system of linear equations. So given the particular problem, you should get the system of linear equation based on the problem. So once you get the system of linear equation, then second step is to transform that system of linear equation in the form of matrix. Whatever system of linear equation you obtain from the question, you transform or represent in the form of matrix. Once you do that, you can solve these equations in the matrix either using you can solve using matrix method or using Cramer's rule. So basically you have to keep in mind these three steps whenever you solve the application of system of linear equations. So now let us go through our example 1 question under application of system of linear equation. An amount of Niltrum 5000 is put into 3 investments at the rate of interest 6%, 7% and 8% per annum respectively. The total annual income is Niltrum 358. If the combined income from the first 2 investment is Niltrum 70 more than the income from the third, find the amount of each investment using matrix algebra and using Cramer's rule. So here we're asked to solve this problem using both the method. First using the matrix method and second using the Cramer's rule. So now let me explain this question clearly before we go to the main solution. So what it's saying is that we have the total amount of Niltrum 5000. We have a total amount of Niltrum 5000. And this total amount of Niltrum 5000 is put into 3 investments. So let's say our investment first one is X and second one is our investment is Y and our third investment let us denote by the variable Z. So if you say that our amount of Niltrum 5000 is put into 3 investments, so our 3 investment can be X, Y and Z. Okay, so this is our 3 investment according to the quotient given here, and then what it's saying is that the amount of Niltrum 5000 is put into 3 investment at the rate of interest. It's saying the rate of interest is 6% for this X and 7% for Y and 8% for this investment C. And the total annual income obtained from investing at this rate of interest for each investment, if you add this total investment, the income you obtain from these three investments is saying the total income is nil term 358. Okay, and next part of the question is that if the income from the first two investment is combined, then if the first two investment is combined together, then it should be equal to the investment of third plus nil term 70. More means it should be plus. So what it's saying is that if you combine the first two investment, our first investment is 6% in X plus second investment is 7% in Y. If you combine, means if you add these two investment, it should be equal. This means it should be equal to the investment, that is third investment, that is Z. More means plus nil term 70. So, since we have three variables, you should have three equations. So our first equation is that the first equation we obtain from this question is that the amount of nil term 5000 is put into three investment. Our three investment are X plus Y plus C. This is our three investment. Okay, this investment is done from the total amount of nil term 5000. This should be our first equation. So since we have three variables, we should have three equations. And second equation we obtain is that the three investments are given at the rate of interest 6% for the first investment, which is X, and 7% for the second investment, Y, and investment for the third is given 8%. So if you invest this amount of at this rate of interest for three investment, the total annual income from this investment should be nil term 358. So that means 6% you invest in X, 7% you invest in Y, and 8% you invest in Z. The total income, if you add all this investment, total income should be 358. This should be our second equation. And from where do you get a third equation? Our last equations come from this sentence. If the combined income from the first two investment is nil term 70 more than the income from the third. What it's saying is that if you combine or add the income of the first two investment, that is 6% in X and 7% in Y, that income should be equal to the nil term 70 more than the third investment. Third investment is 8% of Z. Okay, now let us go to the solution to the problem number 1 or example 1. So let us solve using the first method, which is matrix algebra. Sometimes it is known as matrix inverse method, sometimes it is known as matrix method, sometimes known as matrix algebra method. So it all means the same thing. So in this case, we already know that there are three variables, right? So you can let X, Y, and Z be the investment. You can be the investment at the rate of 6%, 7%, and 8% respectively, right? So that means we are denoting that X is the investment at 6%, Y at 7%, and Z at 8%. So once you let these variables, then you can directly come to the equations. First equation is that if you add these three investments X, Y, and Z, it will come to nil term 5000. In other words, nil term 5000 is put into three investment X, Y, and Z. This is our first equation. And the second equation is that neutron, the rate of 6% investment is put into X, and 7% is invested in Y, and 8% is invested in Z. And if you combine these three investment, the income from these three investments should be equal to neutron 358. So this is our second equation. And how do you get third equation? Our third equation says that if you combine the income from the first and second investment, that is 6% in X and 7% in Y, if you combine these two investment, it should be equal to the third investment plus 70, neutron 70. So this should be our equation 3. So once you get this system of linear equation, you can do some simplification. Okay, so if you want to simplify this first equation you can keep as it is. This is our first equation. To simplify our second equation, to remove this decimal point, you can multiply by 100. If you multiply by 100 to the second equation, you will get 6x plus 7y plus 8z equals to 35,800. That's our second equation. And similarly, you can simplify our third equation by multiplying 100. So we get 6x plus 7y equals to 8z plus 7,000, which is our third equation. So you can simplify this equation further. You can simplify these three equations further. You can keep the equation 1 as it is. 2 you can keep as it is. Equation 2 you can keep as it is. Whereas when it comes to third equation, you can take the variables on the variable side of the equation and keep the constant on the constant side of the equation. So that's why we take this variable at z on the LHS, left hand side of the equation, and you get this, our third equation. So our equation formation is complete. So our next task is to transform or represent this given system of linear equation in the form of matrix. So once you get the system of linear equation, you can transform into matrix. So our matrix A is the coefficient matrix, which is obtained by taking the coefficients of our variables from the equation, which is 1, 1, 1, 6, 7, 8, 6, 7, minus 8. That's our coefficient matrix A. And second is to get the matrix X, which is our variable matrix, which is variables involved in the system of linear equation, which is given by X, Y, and Z. And the third matrix B is our constant matrix, which is given by the constant of the equation 535,800 and 7,000. So once you get the system of linear equation and in the form of matrix, our next step is to find the determinant of A, or the determinant of the coefficient matrix A. Since we are trying to solve this system of linear equation using matrix inverse method or matrix method, first you have to check the determinant of our coefficient matrix A. So when you solve the determinant of the matrix A, we found out that it is equals to negative 16. So since the determinant of this coefficient matrix A is not equals to 0, we can say that the inverse of this matrix exists, and the solution for this matrices can be given or obtained by using this formula. So the solution for this matrix can be obtained, this system of linear equation can be obtained by using this formula, X is equals to A inverse B, because the determinant of A is not equals to 0, A inverse exists. If A inverse exists, then you can find the solution using this formula. So now, next step is to follow this formula, expression given in the formula. So if you look at the expression, we have X is equals to A inverse B. That means you have to find the A inverse. So to get the A inverse, first you have to find the adjoint of A, right? So as you know, as you know, the formula to find the A inverse is equals to 1 by determinant of A times adjoint A. So, as you know, the formula to find the A inverse is using the formula 1 by determinant of A times adjoint A. So, that's what we did here. We calculated the determinant as shown above. We have minus 16. 1 by determinant of A, 1 by determinant of A is 1 by negative 16. And adjoint A, this matrix is our adjoint A. So, how do you find the adjoint A? How do you find the adjoint of the matrix A? So, as you have already gone through how to find the adjoint of the matrix A, adjoint of the matrix A is the transpose of the cofactor matrix A, Cij. Cofactor of the matrix A. Cofactor of the matrix A is the transpose Cij of the cofactor matrix A. So, how do you get the cofactor matrix? So, you have already gone through in the third unit. So, keeping that in mind, we have directly given the adjoint of the matrix A. So, what is adjoint of matrix? Transpose of cofactor matrix. So, therefore, our A inverse is equals to 1 by determinant of A times adjoint A. So, our adjoint A is equals to given by the matrix 1, 1, 2, 15, 1, 96, negative 14, negative 2, 0, negative 1 and 1. This is our adjoint matrix. So, adjoint matrix, and to get the inverse you have to multiply by 1 over determinant of A, which is negative 16. So, final solution. To obtain the solution for x, the formula is A inverse times B. So, A inverse we already obtained above here. So, you can bring it down as it is 1 over negative 16 times this matrix. And what is matrix B? Matrix B is our constant matrix, which is given by 535,800 and 7,000. So, finally, in order to find the value of x, you have to multiply these two matrices. Okay, you have to multiply these two matrices and finally do the multiplication with this scalar quantity, which is 1 over negative 16, to obtain the final answer. So, in this case, if you multiply this matrix, these two matrices, we obtain negative 16,000, negative 35,000 and negative 28,800. And if you further do the scalar multiplication with this quantity to this matrix, you obtain this values. So, which is x, y and z. So, therefore, our final solution is that the x is equals to 1000, y is equals to 2200 and z is equals to 1800. So, now how to solve this same question, our example number 1 question, using the second method, which is using Cramer's rule. It is sometimes known as determinant method, as you have gone through before. So, when you are using this Cramer's rule, I think it is much easier to solve using Cramer's rule compared to the matrix method. So, what you have to do when you solve using determinant method or Cramer's rule is that first you have to find the determinant of the coefficient matrix, the D here. D is the determinant of the coefficient matrix. So, when you find the determinant of the coefficient matrix A, our final answer we got is negative 16. Okay. Once you get the determinant of this coefficient matrix A, you have to check whether the determinant of this coefficient matrix A is equals to 0 or not equals to 0. Whenever the determinant of this coefficient matrix A is not equals to 0, we say that this system of linear equation has a unique solution. And the solution can be obtained by using the formula x is equals to d1 divided by d and y is equals to d2 divided by d and so on, depending upon the number of variables involved in the system of linear equation. Okay, now back to the solution. So since our determinant of our coefficient matrix A is negative 16, it means that this system of linear equation has a solution. So that means you have to find the values of x, y and z. In this case we have three variables x, y and z. To do that, you can obtain the value of x using the formula d1 divided by d. So that means you have to find the value of d1. So in order to find the value of d1, so you have to take the original coefficient matrix A and replace the first column of this coefficient matrix A by the constant matrix B, and put the elements of the constant matrix B in the first column of this coefficient matrix A to obtain the d1. So therefore our d1 is equals to negative 16,000. And once you get the value of d1, our formula to find x is d1 divided by d. d1 is negative 16,000. Is negative 16,000 divided by d is minus 16, which is equals to 1,000. The value of x is 1,000. Next, how to find the value of y? Y is obtained using the formula d2 divided by d. So how do you find d2? d2 is the determinant of the coefficient matrix after replacing the second column of the coefficient matrix A by the constant matrix B. Constant matrix B is 5,000, 35,800 and 7,000. If you replace this, put these values into the second column of the coefficient matrix, and if you find the determinant of this matrix, you will get the value of d2, which is the determinant after changing the values for the second column. So therefore you can find the value of y using the formula d2 divided by d, which is equals to 35,200 divided by negative 16, which is equals to 2,200. Next is how to get the value of z. So value of z you can obtain by using the formula d3 divided by d. How do you obtain the value of d3? It is a determinant of the coefficient matrix after replacing the third column of the coefficient matrix by our constant matrix B. So which is here. So if you solve this, we get a final answer for the determinant d3, which is equals to negative 28,800. So if you plug into the formula d3 divided by d, which is minus 28,800 divided by minus 16, which comes to 18. So therefore the z is equals to 1800. So finally you can write that our final solution to the system of linear equation is x is equals to 1000, y is equals to 2200 and z is equals to 1800.